if I've got some matrix A, we learned several videos ago that its row space is the same thing as the column space of its transpose. So that right there is the row space of A. That this thing's orthogonal complement, so the set of all of the vectors that are orthogonal to this, so its orthogonal complement is equal to the null space of A. And essentially the same result, if you switch A and A transpose, we also learned that the orthogonal complement of the column space of A, is equal to the left null space of A, which is the same thing as the null space of A transpose. So we could write this just to understand the terminology. That's the left null space, which is the same thing as the null space of A transpose. Now, what is the orthogonal complement of the null space of A? What is the orthogonal complement of the null space of A? Well, you might guess that it's the row space of A, but we didn't have the tools until the last video to figure that out. In the last video, we saw that if we take the orthogonal complement, let me write it this way. If we were to take the orthogonal complement of the orthogonal complement, it equals the original subspace. So now, what are we doing? We're taking the orthogonal complement of the null space of A. Well, the null space of A is just this thing right here. The null space of A is that thing right there. So this is equal to taking the orthogonal complement of the null space of A. But the null space of A is this thing. It's the row space's orthogonal complement. Now, we're essentially taking the orthogonal complement of the orthogonal complement. So we can use this property, which we just proved in the last video, to say that this is equal to just the row space of A, which is the same thing as the column space of A transpose. So the orthogonal complement of the row space is the null space, and the orthogonal complement of the null space is the row space. And we can apply that same property on this side right here. What is the orthogonal complement? What is the orthogonal complement of the left null space? The left null space of A. What is this? Well, this is going to be equal to the orthogonal complement of this thing, because that's what the left null space of A is equal to. So it's equal to the orthogonal complement of the orthogonal complement of the column space. And we just learned in the last video, if you take the orthogonal complement of the orthogonal complement, it equals the original subspace. So this is just equal to the column space of A. So we now see some nice symmetry. The null space is the orthogonal complement of the row space, and then we see that the row space is the orthogonal complement of the null space. Similarly, the left null space is the orthogonal complement of the column space, and the column space is the orthogonal complement of the left null space. So we have some nice symmetry that we're able to essentially prove given what we saw in the last video.